Hi everyone, my name is Sydney Cumby. This is my test wrapper 3. So the problem I'm going to be solving on test 3 is problem 4. This was the hardest problem for me. So I'll start off by talking about the goal of this problem. It's to find the net magnetic force exerted by a long straight wire on a rectangular loop. The loop is given to us. So first we have to understand how to set up the problem. We have a current that's carrying upwards, then we have the current of the rectangular loop that flows clockwise, and then we have a height and a width and a distance away from the upwards distance d upwards current. So first we need to find the magnetic field from the wire. We do this by using the equation that I'm writing down. We use the right hand rule to find direction. If it curls up, then it goes into the page, and then on the right side of the wire. Step 3 is going to be a force on the carrying current, or the current carrying the wire in a magnetic field. To use this, we're going to have F is equal to I times L cross B, where L is going to be the vector in the direction of the current, and B will be the magnetic field vector. We're going to use this for each segment on the loop. So then we have to find which segments do not feel the net force. So we know that the top and bottom are horizontal, and they're equal distances away and carry opposite currents, so their forces cancel. So only the right and the left vertical segments feel a net force. So now we're going to find the force on the left side. We know that the distance from the wire is d, the height is h, the current is going downward, and then the field is going into the page. So using the right hand rule, our palm faces to the left and the force is going towards the wire, so it's curling into the page. And then we find our magnitude. That is the equation I'm writing right now. Then we're going to find the force on the right side. So we know that the distance on this one is going to be d plus w. The length is still h. The current is going upward, and then the field is going into the page. So we're using the right hand rule again. The palm goes to the right, so now the force is going away from the wire. And then find the magnitude, which I've shown here. Then we have our final step, the net force, which is going to be F net is equal to F of right minus F of left. So when we plug in the expressions into the equation, that's when we get the answer of F total, which is shown here in the negative x direction. Thank you.